All right, well, so welcome to StartPad. I'm glad to see such a great turnout tonight, and despite the sunny day, despite the Mariners game, and I think we have, one of the main reasons is we have a really interesting speaker, I think, this week, and a lot of people interested in using Amazon services. So I'm going to give a quick overview of what we're doing here at StartPad. As I said, for people who are on the tour, we're kind of trying to create a community of software development companies, and in particular, fostering. Is it the center button or? Oh, okay. So the things that we do, we're doing these monthly. Oh, you're projecting on my head. Okay. We do a monthly lecture series. So this is the fourth Tuesday of every month is what the schedule we're trying to keep to now. And we will have both kind of business talks, technical talks. I think our next talk is about a design topic. And if you have other topics you're interested in, I'd love to hear about them. And we'll try to make it happen. So we also have a website, startpad.org. It's free to join that. What we've been trying to do there is collect a database of service providers. We've trolled through all the backlog of the Seattle Tech startups mailing list. Anytime someone recommends a service or a service provider, we try to capture that and put that into an online database so that it's easier to get to than trolling through the last 1,000 emails that have been sent to the mailing list. And there's also a member directory there, so the members can find each other and maybe find people with skill sets that you're looking for and things like that. We also do Office. Kind of the main thing we do that generates revenue for the company is to kind of help us break even is just to rent out this space, and we have 7 companies working here, and we have a couple offices still available, both on a day pass basis or month to month. So I want to talk about next month's countdown number 7. It will be about a design topic. It's about the site sampa.com. They just did a very major redesign of the website, and we're going to have the designer come talk to us about what it was that they recognized as problems in that website and what they did to address it and what kind of usability results they're seeing as a result of that. That site's been live, I think, now for about 2 months. So that'll be really interesting, I think, to see if what they expected to get out of it was something that they actually saw positive results for that design makeover. Also, immediately after this event tonight, we're having Nathan's going to be leading a pub crawl where they've made it to in the crawl. So anyway, we wanted to introduce tonight's speaker. Obviously, a major concern for software web service companies is how do you actually get your stuff hosted, and how do you get it live on the web? And there are a lot of very complicated issues with doing this well. Traditionally you could buy shared hosting or virtual hosting from traditional ISPs. There are lots of different options popping up now. It's actually kind of complicated to compare apples to apples. You have virtual servers and kind of the general category of kind of these bigger companies that are creating cloud computing initiatives where you're not necessarily buying space on one machine or one hard drive at a time. And so I would definitely say Amazon, with I think AWS has been launched for a couple years now. And I think it's a really bold move for a company to step out and recognize that this is a new emerging market. And they've obviously, taken the market by storm, and I think have had a lot of great success beyond a lot of people's expectations about how usable this, how useful this service is, and how much people needed something like this. And I think there's been a really strong demand for it. So with that, I'll introduce Jeff Barr, who's the senior web service evangelist for Amazon.
All right, I'm not flat enough to be a good screen, obviously. Cool. All right. Well, thank you all for coming. So I love groups of this size because I can actually see all of your faces, and I'm we can get totally off track if you'd like. Feel free to interrupt, stop, ask me questions, contest anything I have on the slides. I sometimes speak to groups of multiple hundreds up into thousands, and sometimes when you get to that size, you can literally not even see the audience. You get up on a big stage and they darken the room and they shine a whole bunch of lights on the stage, and you have no idea if there's actually anybody in the audience or not, or if they're falling asleep, or if they all got up and left, or if they're looking really, really excited about what you're doing, or if they're furiously coding away on their laptop while you're actually talking, which happens sometimes, which is always a kind of neat compliment. I've had people actually listen to what I said and then start writing code based on what I said before the session even ended, which is kind of a nifty thing to have happen. So just as a little bit of background, I've got a software development background. I've been writing code for a living since I was actually, when I was 16, I worked up in Green Lake at a place called the Retail Computer Store. And this was back in the days of the Altair and the IMSI and so forth in 1976, believe it or not, 76, 77. Worked up there and done a whole bunch of interesting things since then. Moved back to the East Coast for a long, long time. Moved back to Seattle almost 11 years ago. Spent some time at Microsoft, worked on Visual Basic 6. I worked on HTML editing for VisualStudio.net. Had a real interest back then about programmable applications and even programmable websites, which kind of got me directly into web services. I always found whenever I used an application, the application was always pretty close, but never exactly what I wanted to. And so early customization and extension models for applications certainly I found really appealing. And then when I saw web services, I really kind of took customization and extension of sites and applications. Left Microsoft at the height of the dot-com boom to work with some venture capitalists, and these guys had a ton of money that kind of evaporated pretty quickly, but they had this really cool idea of letting me be their technical due diligence guy and sending me out to look at a bunch of startups that they wanted to invest in. And I would go in and check out the technology, check out the people, check out the markets, and kind of give them a go or no-go on what it is that they wanted to invest in. If I thought it was good and they put their money into it, I often would get to be in these new companies for a little bit and help them to get their first product or two out the door. I'd be their temporary CTO or their temporary engineering VP. That was really neat. This was back in 2000, 2001. And a lot of those companies that we were working with were all had this common thing. They were all working with XML. They were working with SOAP. They were trying hard to do web service kinds of things. But back then, if you think back to the web services state of the art back then, it was a buzzword that was floating around, and people were arguing about really esoteric aspects of the SOAP protocol and things like that. And then you'd say, show me something. And they would always draw the same picture. You draw the internet. You would then draw this their application connecting up to the internet, and you draw this kind of cloudy thing. You say, well, over here in this cloud, we have a stock quote service or a weather service. And if you're kind of geeky, you could kind of appreciate how cool it was to make a connection across the internet to that service and tell it to do something. It would do something and return the data back to you. Most people would look at that and say, this doesn't really do a whole lot for me. You know, big deal. You showed me the weather. You got me a stock quote. Not really all that impressive to people. So going on 6 years ago, I happened to log into my Amazon Associates account one day, and this little box popped up on the side, and it said, Amazon now has XML. I thought, oh, XML, I know what that's all about. I better check this out. Turned out that just that very day, Amazon had rolled out XML access to the Amazon product catalog. And what way back in 2002, 2003 was called the Amazon Web Service, and has subsequently had a couple different names as we've really refined what that's all about. So I logged into my account, and I signed up for this beta program, downloaded all this stuff, looked at it, and immediately thought, oh, gee, I've been doing XML for a while. I can tell these guys how to do it really right. So I sent up this big email to them, telling them all about what I thought, how it should be done. And so they quickly responded, actually, and said, we love all this feedback. We're very customer focused, so we want to have all this feedback from you. Come on over and tell us about it in person. So I thought, that's kind of neat. Went over to visit with Amazon. Couple steps later, helping, giving them some feedback. And then one day they said, we're getting pretty close to a release on this first web service. And this we're still talking late 2002. We're getting pretty close to this first web service. They invited me and about 4 or 5 other developers from around the world to Amazon headquarters so we could kind of get a little bit of, quote, the vision, hear all about what they're thinking, where they're going to be going with this. So went up there to the Amazon PacMed building, the Pacific Medical Hospital, which is not too far from here, up on the top of the hill, that big Ghostbuster-looking kind of building. Went up there, and at that point, I really didn't know a whole lot about Amazon. I certainly bought my share of HTML and Perl books and so forth from Amazon, but really kind of didn't get a good sense of what they were technically for quite a while. So I get up there to this really cool meeting room and start listening to all these Amazon executives talking about what they're thinking with web services and what they're going to be able to do in the future. And it suddenly struck me, right, that very day, it was really clear they were going to take Amazon.com, the company, kind of pull the covers off of it, and put APIs, application programming interfaces, to various parts of the company, and then invite developers to come in and build things on top of this. That was really just, for some reason, kind of, sometimes the sky opens up and say, wow, I can kind of see the future a little bit. And I saw that future, and my time at Microsoft, I really had this good understanding of the value of being a platform. And thinking about that, realized, that you just don't see platforms come up out of nowhere all that often in the history of the computer world. So I immediately decided I've got to be part of this. So I turned to the person who'd invited me to this conference, and I told her, I said, I'm not quite sure what you guys are doing here, but I need to be a part of it, and I need you guys to interview me to be on your team. So she said, that's kind of cool. We kind of hoped that would be a possible outcome of this day anyway. So they did, and they brought me on board in August of 2002, which now sounds like kind of ancient history. Came on board, and at that point there was a kind of a brand new web services team, and on the side there was another very closely allied team called Amazon Associates. So Amazon Associates, what their business is, they allow website owners to take Amazon catalog content, put it on their own websites, and then earn referral fees and commissions based on traffic coming into Amazon. So the Associates team and this initial web services team were side by side and shared some folks and technology back and forth. So I got hired into this Associates team, and they said, okay, we know you wanted to work on web services. We need you mostly to focus on Associates, but spend 10% of your time helping out this brand new web services effort. So that sounded pretty interesting, and they didn't really structure what it is I needed to be doing. My manager was really flexible. He said, whatever those guys need, just help them out a little bit. His sense, I think, was that maybe they had a lot of engineering, not a whole lot of marketing happening at that point. So a couple weeks into doing that, and I helped him with a number of different kind of little coding tasks and so forth as I'm getting acquainted with the company. And before long, somebody comes to me just a little bit apologetically and says, well, Jeff, you're the new guy. You're stuck with this one. I'm like, what are you guys talking about? And they said, well, we accepted this conference talk, and none of us want to do it, so you're the new guy. You're stuck with it. You got to go out and talk about web services and do a presentation. So most of these developers were scared to death of going out and doing something in public. I had actually done enough presentations in my life. I thought that was just a fun thing to do. So I said, sure, I'll take care of that. No problem. Went off and did it. A week later, oh, guess what? We got another one. And before I knew it, that little 10% of my time kind of stepped up 10% of the time. So all of a sudden, I was pretty much doing web services things full time for them. And they said, okay, we're going to open up this new job called Web Services Evangelist, and you're pretty much already doing it, but we're a big company, so you need to actually formally apply and be interviewed and everything to actually get the job. Went through all those neat steps, and they said, okay, of course, you're now the official Web Services Evangelist. And I said, okay, what do you want me to do? And they said, it's actually pretty simple. Just go out and make these services really, really popular. And that was pretty straightforward kind of job description. That was April of 2003, believe it or not. So since then, it's been the most amazing career of my life. I think of all the things I've done, they've all been fun and interesting and worthwhile. But getting it, in the almost the beginning of this escalator that seemingly is just going to the sky is a pretty rare thing to do. And pretty much every day I'm just really thankful for what it is that I'm doing and just excited about what it is that I'm part of here. In fact, I'm thinking back on all the jobs I've had. Pretty much every job has gotten really boring after 18 months. So I'm kind of thinking, okay, this is it. I've kind of consumed all the interesting parts of the job. It's now turned into this fairly routine kind of a thing. What am I supposed to do next? And now 6 years in at Amazon, I'm still totally excited every day of like, what are we going to do next? In fact, we've got stuff we're rolling out tomorrow. I've already written a blog post for a cool new feature we'll be rolling out tomorrow. So I started there as a developer, quickly transitioned into being an evangelist. I also get to do a lot of other fun things. I now get to manage a team. In fact, one of my new teammates, Simone, is here. He just joined us from Italy just this week. He literally started a week ago Monday, and he's here for a couple weeks of training. He's going to be based in Luxembourg and is going to be doing exactly what I do, but hopefully better in Europe. So we actually now so from these humble beginnings, we've now got a total of myself and 3 more evangelists. We cover the world. We go out. We go to conferences and user groups and one-on-one developer meetings. Also, Satan is part of our developer support team. He's back there as well. So between the 3 of us, we should be able to answer tons and tons of your questions. So my team would go out. We talk a bunch. And so supposedly the company thinks that we're supposed to just go out and talk. That's fun, but we do that all the time. The other important thing we do is we get to also listen a whole bunch. So we go out and in all of our meetings, in all the presentations, and we actually, whenever we go somewhere, we also try to do a lot of individual one-on-one meetings with individuals, with developers, with large-scale organizations. Get to do a whole bunch of listening as well. So our job kind of was supposedly just talking, but there's a whole lot of listening where we get to actually hear from our community, hear from users, potential users, non-users that would like to be users. We take all that feedback, we do our best to actually feed that back into the company, into the product development process. So we write a trip report as we travel every day, and literally hundreds of people around the company get to listen and kind of virtually experience all the different things that we hear out in the field. And you hear companies talk about being customer driven all the time, kind of as an all-purpose kind of platitude. We actually do a lot of listening at Amazon. And so if you have comments, complaints, suggestions, if you've already used our services and you think they're great, we want to know that. If you think they suck and there's something wrong with them, we really actually want to know that too. So please don't hesitate to let any of us know, and we'll actually, believe it or not, that'll be in the hands of the right people maybe tonight or probably tomorrow. By the way, how many existing Amazon Web Services users do we have here? Oh, very, very cool. Anybody who's tried it and said, this doesn't work for me, it sucks, it's no good? Cool, all right. You can put down all your weapons to 10 now that you're okay now. No, it's actually good to get feedback from non-users, because sometimes they'll say, you know, we were 90% of there, but that last 10% you didn't quite do right. And that last 10%, you don't always get to hear that. So getting that feedback firsthand is the most useful thing in the world. So again, interrupt, ask me questions as we go along. A couple interesting things to remember. The Amazon Web Services AWS site is aws.amazon.com. Our blog is aws.typepad.com, and you can email me at jbarr, J-B-A-R-R, at amazon.com. So when I say cloud computing, how many folks know what cloud computing might be all about? Okay, about half. So cloud computing is this phrase that seemed to take on a life of its own, I'd say less than a year ago. We suddenly started to say, people look at what we're doing in other companies and say, okay, this is cloud computing, all these massive servers kind of online, available for people to use, on-demand, shared resources, capacity that you use as you need it, pay-as-you-go kind of a model. People started to put all those different attributes together and say, this is what Amazon is doing. We'll call it cloud computing. Definitely a very, very new emerging trend. Some audiences I go to, a lot of people are familiar with it, kind of have a pretty good intuitive grasp of what it's all about. Other places we go, they're totally just not getting it at all, where they're just kind of, I think I possibly could have heard of that, but I don't even know what it's all about. So those of you that know about it, you're right there at the leading edge of where the world is going. So interesting attributes of cloud computing. So abstracted resources. Now, one of the things that when you go to your traditional hosting companies, you go to that hosting company, they give you a very, very detailed spec of exactly what resources you're going to get. They're going to say, we'll give you a server that's like this brand of server and this kind of hard disk spinning at this exact speed. They give you tons and tons of interesting details that when you go to cloud computing, one of the things that people need to actually learn to do a little bit is kind of raise up your abstraction level a little bit and say, all those specs are interesting, they're somewhat important to me, but let me treat the cloud a little bit more abstractly and say, let me simply make resource requests to that cloud, ask it for what I need, take what comes back from the cloud, and not get so hung up on exact clock rates and speeds and so forth, and say, how do I build applications that can actually adapt dynamically to the attributes and characteristics of the cloud? We think cloud computing is a very cost-effective way to process for a couple different ways. So the first is the traditional hosting model. You typically, at any given point in your site's life, you have kind of an expected number of users. You know pretty much how many users a particular server can support, either for processing time or for storage. You do the math, you divide it out, and you say, okay, we will put one server for every 10,000 users, and you'll just kind of scale up based on your user base and your traffic. So a fairly static kind of a configuration system, and also one that as you grow, you need to go out and request more hardware. You need to make long-term commitments to that hardware. So you don't really have any ability to adapt to demand. You can't really scale up or scale down in a matter of hours or even minutes if you need to. So first, cost effective because you scale up when you actually need the resources. You use those resources. When you're done, you literally put them back in the cloud, let somebody else use them. And also, if it's Amazon cloud computing, one of the real core and interesting aspects of the way we do business, we're always working on driving down costs. We're looking at the cost of retail products. We're looking at the cost of cloud computing. And we're always saying, how can we maintain the level of quality and of service that we have, but still actually what can we factor out, what can we reduce, what can we eliminate to push those costs down even even further. So we do believe actually, and I'll show you some prices tonight, that cloud computing itself is a very, very cost-effective way to process. I'm going to talk about a couple different customers that have been able to scale up and scale down very, very quickly in response to demand. In particular, one customer went from using 75 servers up to over 3,500 servers in the course of a Monday through a Thursday. So think about your traditional hosting provider and say, if you call your hosting provider and say, got a lot of traffic coming in, I think I need 500 servers tomorrow, and I need another 2,000 a day after, another 1,000 after that. Most hosts are going to say, you got to be kidding me. I mean, we just can't do that. Whereas the cloud computing model says, you ask for what you need, when you need it, the cloud responds in a matter of minutes, says, okay, here's your servers, here's your storage, use them. When you're done, shut them all down, relinquish them back to the cloud, and you're all done. Very, very fault tolerant, but also very high reliability. The same operational models that have kept Amazon.com running, reliable, scalable, operating efficiently for the last 13 years or so that we've been a company. That same exact operational model, the ways that we choose to build data centers, the way that we choose to partition functionality, the way that we manage and monitor and provision and get bandwidth and so forth, all those things that are things that we've learned the hard way as we've built our business up, those are available to you now on a pay-as-you-go, server by server, hour by hour, byte by byte basis. So that as a startup, you can when let's say you're a startup, you've got your business nice and you've got your modest-sized customer base. Let's say your first big customer comes along and says, okay, this looks great, but I see you guys sitting behind your desk, and I see your server behind your desk. What kind of infrastructure can I get? What kind of infrastructure do you guys have? What can I actually expect as far as performance and reliability? If you can turn to your customer and say, well, I've got Amazon.com infrastructure, and the same folks that are managing Amazon.com infrastructure are taking care of my own server, that should give you a pretty powerful statement to be able to give to your customers and give you a lot of credibility in your customers' eyes. In fact, one of the interesting things we're starting to hear from venture capitalists is venture capitalists will ask potential companies that they invest in, they'll say, are you using Amazon Web Services? And if so, why not? And if they hear a yes, then they'll say, okay, that's cool. If they hear that they're not using them, then they'll say, okay, what doesn't Amazon do that you guys need? And there's certainly totally legitimate reasons not to use us for any number of kinds of things. But if they hear from these potential companies, if they say, well, we've never even heard of it, that kind of gives them a sense, well, these companies aren't really paying attention to what's going on in the market space. I probably don't even want to give them any further consideration. So at the very, very least, make sure you have your AWS story straight before you go out and speak to any venture capitalists. Okay, so other economics, and we'll get to actual block diagrams and cool stuff in just a minute, but I always want to set the stage first of kind of the interesting attributes of cloud computing. So you don't invest up front, you don't build a data center, you don't buy racks, you don't buy servers, you don't arrange for power and cooling and bandwidth for your worst case. You can start small, pay as you grow, use exactly what you need from the cloud. The APIs, the conceptual models that we give you, we try to keep as very clean, organized, and straightforward as possible so that you can look at what we have, you can study the docs, you can use our libraries, you can use tools from us and from others. Hopefully get started very, very quickly. And not spend time on infrastructure, spend time focusing on your product, on your application. So now let's, any questions before we kind of dive a little bit deeper? Now we've got kind of the marketing side of the presentation behind us. Questions?
Has the healthcare industry got involved in your research?
Yeah, so that's so question number 2 will probably be, what about HIPAA apps, I suppose, right? Okay, so if you don't know, HIPAA is basically a way that if you're building a healthcare application and you have personally identifiable data in your database, you need to keep that safe and secure in a certain way so that you can trust if you give data to your doctor, it's not on some public server in some $5 a day hosting location or anything like that. The Amazon data centers themselves, we cannot certify anything there as HIPAA compatible because that's an application requirement. We have, that I know of, at least 3 different HIPAA applications running in the Amazon cloud. We haven't actually written up all the steps you need to do to build a HIPAA application in the cloud, but clearly at least 3 of our customers have actually figured this out for themselves and are doing it. I know that I'm talking to at least one hospital now that's looking at this and saying there's a lot of good attributes in cloud computing for patient information systems and registrations and so forth. If you'd like, we could talk afterward. I could get you a little bit more information on these companies that are doing that. So it's I'd say for a lot of the healthcare industry, they're looking at this and they're saying this is a little bit leading edge for us, but it's something we know we need to pay attention to. But those on the leading edge are actually saying we can actually build an app and we can make it work within the HIPAA rules and guidelines to make that happen. Was there another question back there?
Do you have a white paper or a sample or something that talks about cost-benefit analysis?
I don't have either those so far. What I do have is something that's called the AWS Simple Calculator, and it's a little JavaScript application you can pull up. And what you can do with that calculator is you can actually you can select the services you're going to use, and you can then tell it basically how much of each different resource of bandwidth and the computing power and messaging, and it will then compute. You kind of give it the raw numbers. It will then compute a monthly cost for you. I know I've actually been in a couple places, kind of the more kind of a corporate paid places where they say, give me like an ROI calculation spreadsheet and things like that. Would actually be a pretty cool thing for us to have. We haven't done that yet. I think that'd be like an MBA summer project level kind of a thing to do. But the calculator, we could actually, you can, if you actually just hit Google with AWS Simple Calculator, I think you'll find that pretty readily. Okay, so this is my non-artistic attempt to kind of build up the cloud step by step. I actually was presenting at a Sun conference a couple weeks ago, and at the last minute they said, well, you can't have PowerPoint, you have OpenOffice. And I had no idea what was going to convey from PowerPoint to OpenOffice. I figured no curvy lines, no animation. I'm just going to go for plain, simple geometric shapes and no animation. And it actually turned out to be pretty good. And so I actually like this concept I've come up with of just building the cloud up step by step before your eyes. So the first thing that we did, we said, okay, we need a separate domain. We need AmazonAWS.com. Of course, connect that online, and we'll build a data center, and we'll give it the power and cooling and bandwidth and monitoring and so forth. And let's start actually populating that with cloud components. Okay? So we let developers register for free developer accounts. You can simply go to that address I gave you, the aws.amazon.com. You sign up for a developer account, and so when I talked at the beginning of my job, they said, make these services really popular. Our developer community is now 370,000 developers, and that's just been a real nice growth year after year. We had about, I think about 30 to 40,000 developers a quarter right now. So you get your free developer account. For all the services, we have both REST and SOAP-style APIs into the cloud. If you're using SOAP, we have all the WSDL files that are needed to load up into your development tool to make SOAP calls. Tons and tons of documentation, lots of sample code, usage-based billing. And then so the common element of billing across all different services is bandwidth flowing in and out of the data center. It's 10 cents a gigabyte for data flowing into the data center. And then there's a sliding scale based on how much you transfer that starts at 17 cents and goes down to 10 cents per gigabyte based on how much you transfer. We actually measure exactly how much you use. We don't round up to nearest gigabyte or anything like that. If you use a fraction of a gigabyte, you'll pay for that exact fraction. In fact, many new developers, they sign up for their account, they transfer a little bit of data in, they start up a compute instance or two, they build up a bill of 10, 15, 20 cents for the first month. That's fine. We're happy with that level of developer. At some point, they say, okay, we're going to go large scale and start ramping up into tens, hundreds, thousands, tens of thousands of dollars a month as well. And we love those kinds of customers too, of course. So there's multiple tiers of bandwidth usage. So the 10 cents a gigabyte for data going in, and at the highest tier, when you're doing 150 plus terabytes a month of data going out of the data center, that'll cost you 10 cents a gigabyte for that data flowing out of the data center. So we have very, very large scale customers doing tens, even hundreds of terabytes per month. Question in the front?
Do you have any locations, physical locations where you can go where you're sort of inside the network where you can just like dump massive quantities?
You know what? This comes up regularly from, I'd say every talk now somebody asks for that. Like you want kind of an ingestion point where like you could like show up with a 747 full of CDs and.
Terabyte a day. I think we actually need to do that at some point. It comes up a lot that people say either bandwidth cost or simply just the fact that you have multiple tens of terabytes of data. People say, exactly, right. So one of our data centers happens to be located fairly close to a really big airport, and that could be a thing that we could do at some point. The question is, like, what would you bring? Would you bring CDs? Would you bring DVDs? Would you bring, like, hard drives that we'd have to have adapters for? Floppies, yeah, okay. Yeah, okay. Yeah, 5-inch floppy drives and 8-inch floppy drives, probably not. Be worth it for anything unless I
Yeah.
terabyte of stuff, so, external hard drive and a computer, so.
Yeah, I would say like before you actually decide that was an absolute necessity to actually benchmark what you try to do, and then there's actually when you're doing huge high volume data transfers, there's a lot of tuning you can do at the TCP/IP level to get the ultimate in performance from that. So before you say it's too slow for me, figure out a way to at least give it a shot At the same time, keep pushing on us for some kind of ingestion center, because it does come up from time to time, and if it comes up enough, we're going to have to really figure out a way to do that. Because I do talk to people from time to time that simply have like vast databases that they're building, and they say even at the highest possible transfer rate they can get on their end, that it just doesn't make, they don't have the time to push it in. So good question. There was another question toward the back.
Yeah, it kind of on the same line, public peering at the network level.
Mm-hmm.
And is every time I talk to someone about Amazon, about peering at the 6 or something like that here in Seattle, it's always kind of pushed out, 8 weeks, 8 weeks, 8 weeks.
Uh-huh.
And
what was that thing, the 6 you called it?
6.
I've never heard of that. Okay, yeah.
Any sort of public peering around the world, around the U.S. would be awesome. And
So have you actually been able to do trace routes and decide that we're not peered the way that we'd need to be for your particular application?
yeah,
We're not. Okay.
you network people are saying it'll happen.
Yeah. It just so happens I'm meeting with one of the guys that does that stuff tomorrow. Actually, I'll give you my card. If you can email me what you're looking for today, or maybe like tomorrow before like 11, would be awesome, because I'm going to meet with him tomorrow, and I'd love to bring that up and get his response. Generally, when we do those things, in the past, that was kind of a transparent, not really needed to be disclosed part of how we connect. Things are coming up from time to time where people say if we're actually peered through a particular location that their application will work, otherwise the latency is just simply too high. So one of the things I always do is try to get us to be a little bit more open with the things that we're doing, and I'm going to try to see what more can we say about where we're peered and where we're going with that. But getting a specific request exactly of where we need to be and why the existing ones don't work for you would be a really, really helpful thing to get. So please feel free to let me know just as quickly as possible. And I know that in other situations, there have been requests like that, and with enough requests and where we can actually make the business case for it, we get that public peering to actually happen. Another question? Cool. All right, great questions. Okay, so we're building this cloud. So the first thing that we put in the cloud was a message queue system, because we know that we're going to have people in this cloud building highly scalable applications. Now, when you build a highly scalable application, one of the real things you think about as you design it is you build it in very loosely coupled fashion. You try to have enough independent moving parts so that each different moving part might be doing a different part of the processing. You don't have synchronous calls from machine to machine. You use message queues where if different parts of your system are working at different speeds, or if you want to have a degree of fault tolerance, so if one of those processing steps in your pipeline becomes stalled or real slow or gets overloaded or maybe even goes offline momentarily, if you build a system out of message queues and you glue it together with all these message queues, you can have a very, very resilient, very fault-tolerant system where the message queues represent work being passed from stage to stage along the system, and you can simply absorb all that work inside the message queues. So the first service is called SQS, the Simple Queue Service, and this is just a scalable message queue, totally elastic capacity. Inside your Amazon developer account, you create any number of message queues you'd like. You can then effectively load those up with as many messages as you'd like. There's a certain fixed upper limit on the actual messages themselves. It's a pretty generous limit. One thing I should address is that word simple in the title. You'll see simple in the names of a couple of our services. Now, this doesn't mean we dreamed them up on a Friday and wrote code all weekend and put them online on a Monday. The simple is supposed to refer to the conceptual model that we're giving to you for the service. So instead of giving you systems with hundreds of very, very complex APIs that are high level, we try to go down a little bit at a somewhat lower level, give you these very functional but not super feature-rich kinds of primitives, with the idea being you take those primitives, and if you want something more complex, we should have given you enough power to layer additional functionality on top of whatever it is that we give you as a base. So hence the names like Simple Queue Service, Simple Storage Service, and so forth. Engineering all these services for internet scale is, of course, not simple at all. I think we've got some of the best engineers in the world, and people that know how to build these things, that high degree of scale and reliability it takes to do that. Okay, so we had message queues. Next thing is we said people want to store blocks of data in the cloud, so let's figure out a way to do object storage. Came up with Amazon S3, again, the simple storage service. This is scalable object storage in the cloud. It's distributed and redundant, so you make one store request into the cloud. You give us a block of data that might be anywhere from 1 byte up to 5 gigabytes of data at a time. You hand us that block of data. There's APIs, and you can also do it through an HTTP post. You post that data to us. You hand us that data. As soon as we get the data, we immediately copy it to several different locations across a couple different geographically dispersed data centers, so we have multiple redundant copies of your data. We then assign an access control list to your object. You then have full control to then modify that access control list. So by default, you store something with us, and it's fully private. Only your authenticated request can get to that data or delete it or change it in any way. If you'd like, you can make those data items public. If you want, let's say, to put web objects in there. Maybe you want to store static web pages or images or videos or other kinds of multimedia files in S3. You can simply put a public attribute on each of those objects you want to share. Every object automatically gets a unique URL when you store it into S3. So every object has a URL, and you can simply hand out those URLs just like any other object stored on your server. Storage sells for 15 cents per gigabyte per month for exactly how much you store. So if you store exactly 1 gigabyte for a regular month, you'll be charged 15 cents at the end of your month to the credit card attached to your Amazon developer account. You store, let's say, a third of a gigabyte, so you'll pay 5 cents a gigabyte per month. We sample how much you have stored multiple times per day. So as your storage goes up and down throughout the day, we have a fairly accurate capture of how much you have stored. At any point, you can log into your developer account, and you can actually see exactly how much storage you've used up to that point in time for the month. You can see what your bill is at that point in time during the month. So object-based storage in the cloud. How many S3 users do we have out there? Cool. What kinds of things are people using it for? Backups. Okay. Good use case. I've got almost 30,000 pictures in my S3 account, so I can appreciate that.
You guys thought about doing any, how recently you started sliding scale for bandwidth?
Mm-hmm. Not that I know of. I don't think it's come up too often, but certainly something we could kind of think about for the future. I know some of our largest customers are at the 500 plus terabyte level, and I don't know that at that point that they're looking for better pricing or not, but people have been pretty happy with the level so far. So kind of an idea of the scale of S3. We now have about 18 billion objects stored in S3. And we do somewhere around 30 to 50,000 transactions per second against the data. So this is a very, very busy, very large-scale storage system. S3 question?
Do you allow the host name in the URL to be under our control so we can have Flash players don't like to play things that are in the...
Yeah, so what you can actually do is you can actually, when you create your own S3 storage, you have control of everything is stored under AmazonAWS.com. The next level in is called a bucket, and you can control the name of those buckets. So like I have a bucket called jbar, so I have jbar.amazonaws.com. Now, you can actually put a little tag inside that bucket that actually will essentially let you use your own top-level DNS name for that bucket. So I can actually put an entire website inside of a bucket and then have that bucket respond to that DNS name. I didn't need to go to my DNS provider and make what's called a CNAME entry to point to that bucket. But you can do that. If you're doing a Flash player, I know with the Flash player you need to put a little XML file in the root of that bucket as well to basically, it's what like cross-domain security or something you need to enable with Flash. But there's definitely people have done that with S3.
That's not an extra fee or?
No, that's just part of the way it works. Question back there?
So, do you guys see S3, at least one slice of S3 being a competitor to CDNs?
I think they're slightly different than the traditional content distribution network. The S3 has a much more limited set of points of presence around the world. There's a set of S3 installations in the US. There's a separate installation in Europe, and we did that because, in fact, I made about a bunch of trips to Europe last year, and they said, we need a way to keep our data out of the hands of the US, and we'll just keep it over in Europe. And so we actually put a separate S3 install over in Europe, and we now have APIs where you can actually store your data to the US or store your data into Europe, and you can have separate copies of your data in those locations if you'd like. As far as many hundreds of locations with a CDN, we don't have that. Certainly anything's possible for the future as we hear more from what customers are using. One thing that we have heard with respect to CDNs is that when CDNs became very popular, latency and connectivity across the internet was probably not as good as it is right now. And so there's a number of applications that where you would have thought CDN is an absolute necessity. There's a number of things now that are actually totally doable at reasonably low latency with direct access to S3.
Are you guys planning S3 presence in Asia or let's say Brazil?
Not specifically I know of, but we certainly do look at access patterns, and as we get different kinds of requests, we do what we can. We generally don't think as much of specific locations as latencies to locations, and sometimes that can be addressed with better connectivity. Like, for example, one of my other evangelists was in Australia and New Zealand earlier this year, and it turns out that we don't have the best possible peering to Australia and New Zealand. Well, there's one particular network, if we peer with those guys, we should be able to really improve the connectivity, and it's that's definitely on our to-do list to peer with, to get New Zealand and Australia a bit happier with us. So if you've got customers in Brazil, we should talk about that and like what kind of bandwidth we're looking at and so forth to get those kinds of things into the system. Okay. The next thing that we need to add was index storage. So when you store into S3, you're simply giving us this undifferentiated blob. You hand us this block up to 5 gigabytes at a time. It's got a name that you assign, but we don't scan it, we don't index it, we don't look inside it in any way. We have no idea even what kind of data it is unless you put a MIME type on it for web access. We don't know what's inside there. But we had a certain set of customers said we need something a little bit more structured, a bit more high level. So we said, okay, we can help you with that. Have something called Amazon SimpleDB. This is a database in the cloud, indexed data storage. Now this isn't your a little bit different if you're familiar with something like MySQL. This is what people are calling a post-relational database model. So instead of having tables and joins and very, very tightly hardwired schemas, the SimpleDB, the post-relational model, is a little bit more flexible, a little bit less stringent in the way that everything works. Instead of having to pre-declare a schema up front and having to go through downtime when you change schemas and add columns, the post-relational model is more flexible. When you need a new column in there, you simply store a new attribute value pair. The database says, oh, I don't know anything about that attribute. I'll just effectively add a new column simply for that one row stored in the database. If you want, you can be very structured and very disciplined in the way you use that database, and you can always make sure that every row that you have has the same attributes. But if your application is evolving rapidly and you don't know exactly what set of attributes you need to have to solve the problem, you can be a little bit more fast and loose with the way you use the data. When something new comes along in your app, you say, okay, I don't know what to do with this. I'll just store it as a new attribute. And a great thing with that means you don't have to go back to all the old records, add that new column in, rewrite the whole database. Quite a bit more flexibility. The SimpleDB is still in beta. It's a limited beta. If it sounds like something you need and you want to get into beta, drop me an email with your Amazon account email, and I'll be happy to get you in there pretty quickly. Schemaless, fully elastic capacity. So unlike a traditional database where you say it's running on this disk drive or this set of disk drives, and you worry all the time about what do I do when I fill up that disk drive? Where am I going to get more space? Or how do I start spanning across multiple volumes? Or what if my one table gets bigger than the size of a physical drive? We take care of all those things inside. You don't have to worry about managing space. You don't have to worry about which things do I index. You don't worry about what was my third thing I was going to say to worry about? Breaking things up when things get too busy. You don't worry about adding more servers and replicating servers to deal with load. That's all transparent and handled for you at the system level. You throw in data, we index it, you make requests to get it back, and all the rest is handled inside for you.
So I mean, just to sort of clarify my thinking, it sounds a lot like a distributed hash table. I mean, is that essentially what it is, or are there significant differences?
I think it's considered a step above a hash table because you actually have these item value pairs. And so any particular row in the database has any number of item value pairs to it. A distributed hash table doesn't have the automatic growth attributes, for example. So the fact when you create what's called a domain in SimpleDB, you create it, you name it, and you start storing things into there. And you can store multiple tens of gigabytes in there if you'd like. You never have to say, is the disk full? Where do I get more space? You never have to make a decision of, these columns are really important, I'll index them, but these I won't even bother to. The system makes all those decisions based on access patterns and the way the data is actually stored and being put to use. Okay, at the center, we said, okay, now we've got all this data and ways to store it and so forth and to communicate. Let's actually put some processing into the mix here. So we have a system called EC2, the Elastic Compute Cloud. The idea here is we have scalable processing power. You make a request to the cloud. You ask for any one of 3 different sizes of machines. You have a small, a medium, and a large, and I'll go into the specs of these in just a little bit. When you make that request to the cloud, you give us a pointer to something that we have called an AMI, an Amazon Machine Image, which is basically like the root disk, the boot disk of your computer. You give us that AMI, you give us your account identification, and you say how many machines you'd like. And you could say, I need 1, I need 10, I need 50, I need 100, I even need 1,000 machines. We find available machines in the cloud. We copy your AMI to the hard drive of the machine. We boot them up. We assign them IP addresses, and we make them available to you in a matter of minutes. So literally, you make a request to the cloud and says, I need 20 machines running this operating system. 2 minutes later, you can have those up and running and running your code if you'd like. We currently support a number of different variants of Linux. We also announced a deal with Sun last month. We support Open Solaris on there. These are virtualized machines. You have full root level access, and they cost anywhere between 10 and 80 cents per hour based on the capacity of the machine that you're getting. Okay? So one of the interesting things about the elastic computing model, these are transient machines. So you make a request from the cloud. We give you your machines. You have a certain amount of CPU power, an amount of RAM, some local disk space. As long as that machine is up and running for you, you've got access to the local disk drive of the machine. At the point when that machine either crashes or you shut it down and relinquish it back to the cloud, you no longer have access to that local storage. So it's great storage for while you're running. It doesn't do you any good once you've shut down these running instances. So people said we need something a little bit more persistent. So we're just about to go into beta on a block storage model for the compute cloud.
Jeff, one question.
Mm-hmm.
So how many of your customers are actually using your Elastic, your EC2s to stay persistent data on the local file system?
Well, what they'll do when they want to do that is they'll do things like replicated databases. They'll do like replicated MySQL databases and run multiple different EC2s at the same time. And then we actually have a feature called availability zones, where the data center is partitioned into different physical spaces. So if you want to have really the highest level of reliability, we give you the ability to say, within EC2, list all the different zones that are available. And then we give you APIs to say, launch some servers in zone 1, launch some more in zone 2, launch some more in zone 3. The zones are architected such that if one of the zones is to go offline, the other zones are not going to be affected. So by launching into zone 1 and zone 2, replicating between them, you have the ability to make something that's very, very fault tolerant of transient or permanent failure of an instance. In the back there.
Are there geographical zones?
Currently, we only have one geography for EC2, but it's clear that from what people are asking us for, that we need to be in more locations. Right now, I believe if you trace route, all the EC2s show up on the east coast of the US. We'll definitely get to more spaces at some point in the future. I don't know where, I don't know when, but clearly there's demand for other locations in the US. There's demand for us to go in other countries as well. We did the same thing for S3. We started S3 in one location in the US, and then based on demand, we said, okay, we need S3 of both the East Coast and the West Coast. We did that. And then people said we need S3 in Europe, so we went ahead and did that one as well. So based on demand and usage and where we see markets growing, we'll definitely grow to other locations. And at that point, you'd expect us to have really a full API where you'd say, show me all the geographic regions I can run things in. And then based on that, we then give you a list of regions. You then make another call that says, within that region, show me all the different zones I can run in. So you could say, maybe you find out that there's a zone on the West Coast, and you say, now give me a list of all the availability locations within that to then have fault tolerance within that. And then you can say, launch some servers here and launch some servers here. When we start doing that, there probably will be some modest charge for bandwidth between different EC2s in different zones, simply because it's not within the confines of a data center anymore. So one of the tricks I've learned in my job is to actually, when I hear about plans for the future at the office, I hear them and I think, wow, that's really pretty cool. And then whenever I hear time frames, I just simply forget about them, because it's too hard to actually advance time frames into the future, because you know how it is. Some things are always 3 weeks in the future, and some things are perpetually a month away. And it's so hard to actually remember those things and to go back to the people that told me about them, that I just don't want to actually know until it's really, really close to release. And also, I just don't want to be liable to be kidnapped and have people torture it out of me and things like that. So it's always I've found it's safer to simply know this is what we're actually doing right now, and the things that we could be doing or we might be doing, just kind of wait until we're really, really close, and then learn a little bit about them at that point. Only because I've seen things that were perpetually a month away from beta for a long, long, long time. And it wasn't that people were not doing their job. It was that the problem itself turned out to be very, very complicated. And I would have actually wasted a bunch of time learning things that might actually not be true at the time we released it. So kind of optimizing for a decreasing number of brain cells over time, basically. There's just way too much to remember in this job for me to even think about the non-public parts of it. I'd say basically things are changing really, really fast. Unlike kind of being a traditional operating system vendor where you've got releases that are measured in multiple years and half decades even. Things change with Amazon Web Services on a pretty much week by week, month by month basis. So if you don't see what we're doing right now, don't write us off for a year. Write us off for a month and check back in a month or two. Check our newsletter, check our blog, check our website, and things are happening pretty fast right now. In fact, some of the stuff I tell you now might be partially obsolete by tomorrow. So, or it'll be better, not obsolete. How about that?
The cost for EC2, and that is if you spin up like an instance of some machine, right, and it's mostly idle, but you need it to respond, it needs to respond. What do you pay for it? You still pay for it?
So you're paying for the actual instance by the hour. So we don't actually have any visibility into is that machine busy or not busy. I do think that actually creates a marketplace for other interesting business models on top of this. So somebody that wanted to actually go ahead and do something like that should actually layer above what we've done and then build a cycle market versus an hourly market and say, I will sell you a fraction of an already virtualized machine at a very, very modest price, with the idea being when that thing starts to actually heat up, we'll actually migrate it in real time across to a more high capacity piece of hardware. There's definitely room to do that, and I actually think that we have all the basic facilities in place in our system. If you want to build that business, go home tonight and start coding it up. There's really no reason you couldn't do that, literally.
Do you have any plans to have any sort of cron job, like create 5 instances at 2 a.m. of a certain type of instance?
Probably not directly from us. That again is something I would expect to be built on top of our API. So as a platform provider, there's always like a million things you can do, but there's a much smaller set of things that you really have to do. So when you build the platform, you have to say, what do we have to do, and what do we then want to leave room on top of for others to do? And so like automatically scheduling and booting up on demand is something I would say that would be a third-party application to do. Exactly right, yeah. Secret notes being passed here. Oh, okay, yeah, cool. Yeah, one of our third-party vendors is a company called RightScale that has a really nifty load management application for EC2 where you actually configure your system config into RightScale. You design up your set of servers that you're running, you give it some parameters of how you'd like it to respond when that set of servers gets too busy, and it will automatically set up an initial collection of servers, and it'll watch memory usage or how busy the CPU is or how full your queues are, and it will then dynamically adjust different parts of your architecture to make sure you have enough horsepower in the system to respond to demand. So that's something that can be built on top of the cloud. We don't have to build it ourselves because a third-party vendor has already built that. Oh, okay, go ahead. Then there's a question in the back there.
The persistent storage, are you guys going to potentially release APIs before you release the actual alpha or beta program? Like, so that people code against it and try to get a head start?
Yeah, so as a blogger, I'm always on the side of more openness and more transparency, and we actually did roll out a blog post a month or two ago that had some details of how the block storage system will work. It was really the first time we'd actually talked about anything before it was really ready to go at all. And the hope is that as we saw, that was actually a great experiment for us of like, is it valuable for us and for our community to be more open? And the overwhelming response was, my gosh, that was really, really worthwhile and really valuable. So in the future, I'd expect that we'll be able to talk more about various APIs before they come out. One thing that we have done is we're working to identify like tool vendors that have management tools for the whole cloud. We're trying to get those guys in the loop a little bit before the beta launch, so that at the point when we say, okay, block storage is now an open beta, we would hope at the point when we launch that open beta that some of the tool vendors have actually prepared their tools so that there's some actual ways to use these new facilities at the launch day. We're learning as we go here. There's a lot of complexity as we build this business, but we're trying real hard to learn to do all the right things. Question in the back.
I think you mentioned RightScale. Came up at another lecture I was at about a month ago, and the question, the later conversation was, do they have special privileges to your services?
Nope.
Anything they can do, we could build.
Exactly right. So that's a really good question. There's no, as far as I know, there are no undocumented APIs into the system. If the undocumented AWS book comes out at some point, then I've been like deceived for quite a while, because I don't think there's any magic stuff that we give out to those guys. So the basic facilities that RightScale uses are simply things like, there's one called Describe Images, and Describe Images simply lists all the different AMIs that are available in the catalog. There is Run Instances, and Run Instances simply says, I need to allocate some servers and run a particular AMI on those servers. There's a number of APIs for managing the security groups. There's others for listing all the running machines you have and to terminate those. But there's no magic that RightScale is doing that you can't do yourself. In fact, there's several different load management applications. There's another one called Cloud Tools. There's another one called Scalar, S-C-A-L-R. These are all companies that are basically just building on top of the cloud APIs to build these management applications.
I'd like to just quickly add to that. It's a great way to learn Amazon Web Services by using their beauty tools and looking at the scripts that generate schemes.
Which particular one are you referring to there?
I use RightScale. So like, building the AMIs, I started with one of their AMIs that they had online just for free. Looked at how they were starting up their build scripts, and kind of started customizing that and seeing how they did it in the background. There's nothing magical there.
View source is always your friend, right?
It's all the actual EC2 API.
Oh, totally cool. Good to hear. I've always found in my life that looking behind the scenes of what's actually inside there and how does this stuff really work is you learn all kinds of stuff. It just always turns out to be worthwhile.
Great way to get started with it.
Excellent. Any more questions on the cloud? Get into block storage here. Okay, so realizing that we needed some way to have persistent storage in the cloud that was block storage and high performance and accessible to EC2, we've got an upcoming release called Persistent Block Storage. Actually, we don't have a name for it. It's not called Persistent Block Storage. We have an upcoming release of a persistent block storage feature. Let me be precise.
Simple, persistent.
This one is anything but simple inside. I've actually peeked at some of the design specs for this. This one is wickedly complicated inside. The idea here is you make a request to the cloud, and you say, I need anywhere between 1 gigabyte and 1 terabyte of persistent, high availability, high performance storage. We allocate that amount from the cloud. You can then mount that onto any of your EC2 instances. If it's a Linux instance, you can then do a makefile system, put a file system of any type on top there you'd like. Connect it up, use it as a file system, and put your database tables on there, put whatever you'd like. I think you can put up to 20 of these volumes on any given EC2 instance. You've got full control of this again from the cloud. So there's actually cloud APIs that say, I don't know the names of these, but you basically allocate a block and attach a block to an EC2, list the set of blocks you have, release a block back to the cloud, and so forth. So literally in a matter of seconds, you can make a request to the cloud and say, I need a terabyte scratch drive. Get that scratch drive, create a file system on it, which takes a little while because the way Linux builds file systems. Put that file system on it, use it for a bit, write all your temp data on there. When you're done, release it back to the cloud, and you'll end up paying just for the amount of storage you have for the amount of time that you use it. Question in the back there.
Do you wipe the data so someone else can allocate that instance and see my data?
Oh yeah, most definitely. So there's a lot of security things that happen behind the scenes here, and I have to be honest that we haven't been as good as we should be about really talking about the security stuff we do. We basically imply and we make it clear that we do all the right things, but we haven't been very transparent about enumerating the actual set of things that we do. That's something we're still working hard to get to that point. Where we found that when we were back as a retail company, the best thing to do about security was to just do all the right things behind the scenes, but you never actually come out and tell people this is what we did, because if you list the 10 things you do, anybody sharp says, oh, here's number 11 they don't do. That's clearly the thing I need to go in and try to break in. We're finding as AWS goes to all different kinds of customers, especially as we get to the enterprise scale customers and governments and schools, they're actually saying, we need a little bit more better statement than trust us. And so we're going to, at some point, we'll have a good blog post or a white paper or something that really goes into a lot of detail about the security models. One thing I can tell you, when you start up a whole bunch of EC2 instances, each of those instances is on, think of it as a virtual network that's only accessible to you. And even once they're started up, they can't see each other, they can't talk to each other until you actually enable explicitly at the IP address and the port level which of those instances can see each other. So if you're building a 3-tier application, you need to actually enable access between each of those tiers and from the outside world. So you boot up a new instance, you can't even SSH into it, you can't even use web browser into it until you turn on access to it. So fully secure. They can't sniff the network, they can't see each other. If a number of different customers happen to be located on the same machines, they can't figure that out, they can't see the traffic. There's no visibility of each other on the virtual network. So I don't have a release date yet for this feature. I've been asked a couple times already tonight. It's going to be very popular. We want to make sure we have it exactly right before we roll it out in beta form. We have a tiny alpha running now. We're taking names for a beta test that should happen in the near future, is about as accurate as I can be, but near future. One really cool thing, you can actually do snapshot backups S3. So you have this gigantic volume there, and at any point you say, I need a backup copy of this. You can back it, you make one call to the cloud. It copies the whole volume out to S3, and it's then available as one of your other S3 data objects. And you can then use that just as backup, or if you say, I only asked for 10 gigabytes, I really needed 12, you can create a new volume based on that original backup that you made. And so it looks to be like going to be a really, really powerful, really flexible feature.
So, just from my notes, S3 only allows 5 gigabytes per object.
Correct.
Is there like sort of automatic object partitioning?
So I've never actually looked yet at what this does. I assume it just takes like 5 gigabyte chunks of your file system and just writes a whole bunch of 5 gigabyte chunks. So, well, but you'd never want to look inside them, right? This is like looking inside of a tar file or something like that. You generally don't look inside of a tar file. It's just that is your backup. And so there's a naming scheme so that it will then pick names for all the pieces of your backup. But it's not going to copy. The thing is the system itself doesn't know what you have stored in there, right? You probably wouldn't. And the fact is that we can't know what's on there because you're going to create one of these blocks and you could put an ext3 file system on there. You could use ZFS. You could put a Windows file system on there if you really wanted to. You could use it as raw database storage. You could use it as like raw Oracle database storage if you wanted to. We don't actually know what you're using it for, so there's no way we can do an application level backup of files. It's just a bunch of bytes as far as we're concerned, and we need to then treat it exactly like that. Any more block storage questions? Cool. Okay, so people wanted permanent control of IP addresses. So we actually made IP addresses yet another resource in the cloud. You can make a request to the cloud to say, allocate an IP address to me, to my Amazon account. You get that IP address. A separate API, you can then map it to any one of your running EC2 instances. You can get up to 5 addresses per account right now. If you need more than 5, we have a procedure where you can get a bigger allocation. But we've been told by the IP address owners, ICANN, they said be really careful with IP addresses and don't just give them out indiscriminately. So we said 5 by default, and if you tell us why you need more than 5, we'll give you a way to do that. You get these addresses, attach them to your instances. If your instances go away or you need to remap them for load balancing or changing needs, you simply reassign those IP addresses. Once you allocate them, they're effectively permanently attached to your account. You can get them, you can keep them effectively forever. We actually charge you only when you're not using the addresses. If you get the addresses and you attach them to your instances, there are no charge for up to 5. If you get them and just hoard them and don't use them, then we actually have to charge you for them. So we give you an incentive to use them. We charge you 1 cent per hour per IP address. So not a huge amount, but still just a little incentive for you to use them rather than just kind of holding on to them without need. So that's just one more cloud resource. So allocate them as needed, attach them to EC2, and then you can remap them. It takes, I think, like a minute or two. If you remap, if you say, my IP address used to be on server 1, I want to go to server 2, we give you an API to actually remap them on the fly to do failover or load balancing.
Supported to map multiple addresses to one EC2 instance? Or?
Yeah, you can do that. You can't do the other thing, though. You can't put multiple EC2s behind the same IP, though. Correct, yeah. Okay, so all these are the functional aspects of the cloud. Also to that, we have 2 other important components down there on the side. We have metering, so we're measuring exactly how much of these services you're using. So as you're consuming these services, we actually track hour by hour how many gigabytes you've stored and how many EC2s you have running and all the different factors that we measure. We measure those. We bill you for those. At any point, you can log into your AWS account. You can see exactly line by line how much you've used multiplied by the costs, and then down the bottom right it shows you this is how much your bill would be at that point in time. Once a month, just like you use your cell phone or your electric or your water, you get an email from Amazon Web Services and it says you've used up this much resources this month. We're about to bill your credit card for this amount, and just you use it on a utility basis. You pay for exactly what you're needing. And in fact, getting all this metering and billing is a really significant part of having this whole infrastructure. The funny thing is when I go out to corporate customers, the corporate customers don't always grasp just how complex all this stuff really is to build. And I'll present these things and they'll look at all this and they'll say, well, to summarize, all you guys really did is you had extra hardware and you put a couple racks online with some IP addresses. And that's all you did. And like, well, it's maybe a bit more complicated than that, you guys. It's actually pretty tough stuff. And they kind of look at me and say, you know, this sounds really easy. I'll bet 1,000 companies could do this in probably a couple weeks if they really wanted to. And I say, look, if they really want to, let them give it a shot and see how complex this is. When you put something like S3 online and you want to scale to multiple tens of billions of objects and, you know, as needed. It's not at all simple. It works extremely well at this point, and you know, of course, we're always hoping and planning for 100% availability and reliability, and doing our best to actually reach that over time. It's fairly complex stuff. Okay, so metering gives us the dynamic usage tracking and the credit card billing and usage reports and the portal you can log into to see your usage as well. So that's kind of the cloud, and now we'll switch into talking a bit more about EC2. And any more kind of general cloud questions before we dig into EC2 some more?
What are the provisions for, I mean, like, I assume that Amazon really tries hard to make sure that none of its cloud services run out of resources. Are there provisions for, like, a standardized set of exceptions, or how?
So basically, when you make a request to the cloud, you make this request, and the request is called run instances. And you say how many machines you'd like, and you actually have a minimum count and a maximum count. And that request can fail. There is finite capacity in the cloud, and there's a call that you could make that could actually you could use either more than we have or more than your count is allowed to use. So
I assume that applies for storage.
Yes. Our goal, of course, is to never run out. And we've been, like, S3 is now a little over 2 years old, and so we actually have a fairly nice graph of where it's been and where it's going. And we get surprised sometimes by how much comes in, but it's not like a 100% surprise of, like, nobody dumped in, you know, an extra, you know, 100 terabytes or something in a given day, or an extra petabyte or something. It's within a range that we say, okay, we understand when you average that out, we kind of know the scale patterns over time in fairly good detail. I mean, when you have a widespread service like this, you can envision the usage just swinging just rapidly from, you know, 0 to gigantic back to 0 and so forth. It's not like a straight line going in any particular direction, but the variance compared to the shape of the line is actually pretty modest. So when I look at, like, usage of EC2 day by day, there's a really nice curve as we get more and more users, but it doesn't swing from, like, you know, we're using most of it to we're using nothing or anything. And part of that was, I think, intentional. We went out and tried to get as many different kinds of customers as we could for it, knowing that they wouldn't all have the same kind of access patterns. So we got some people that are really busy when they start doing, let's say, college registration. Other folks are doing, you know, they're like Amazon. They're doing end of year, you know, holiday sales and so forth. Or they're doing income tax processing, and they're really busy on April 15th. And so you average out all those different kinds of usage, and it turns out into noise, basically, because there's so many different kinds of usage in the cloud that we've got enough. That's kind of that's our job. That's one of the things you basically delegate to the cloud. You're saying, I don't want to have to worry about resource allocation anymore. I'm going to trust those cool guys at Amazon to simply have enough of whatever it is I need when I need it. And within pretty broad parameters and getting bigger as we scale the service, we always do have enough. So, like, right now with EC2 by default, your regular accounts can go up to 20 instances. But if you need more than 20, when we see you starting to use like 15 plus on a regular basis, we'll actually call you or email you and kind of get a sense of where you want to go with it. And you can pretty easily talk us up to a couple hundred, really easily in the space of a couple-minute phone call. If you need to talk us up into the multiple thousands, it might take you 20 minutes or so, but we can do that. We've got customers using multiple thousands of instances pretty regularly. The biggest one I'm aware of is peaked at about 5,000 instances. So I think that's pretty large scale. And then as the service grows, you'll see high thousands up into 10,000s probably becoming routine at some point. So I think we have enough for you. But if you have very special needs, if you're, I don't know, doing drug discovery or molecular modeling or something, or decoding I don't know, SSH keys or something like that, then somebody figured out a way to do that. Actually, they said it was. Well, they figured it would cost them $371,000 to get enough resources, and so this is why we actually want to have that conversation with people. We have a set of terms of service for the cloud, and we know we don't need to know in intimate detail what people are doing, but if it's if it seems a little bit suspicious, then we have the right to actually investigate and make sure we know what's going on in there. And by and large, people are on the up and up. And if it was something that seemed extremely strange, or if it was some three-letter government agency, then I'm sure we'd be asking even more questions, most definitely, and just kind of see what's up there. Okay, so let's talk a bit more about EC2 in depth. So there's 3 different instance sizes: the small, the large, and the extra large, with varying amounts of memory and computing power and local storage. And these go anywhere from 10, 40, up to 80 cents per hour. The smallest one is 32 bits, and the 2 larger ones are both 64 bits. So when you request an instance, when you say run instances to the cloud, you simply tell us which size you would like, and we'll give you as many as you need of that particular size. Important concepts of EC2: you have the AMI, which is the bootable root disk, where you actually has your operating system plus your application pre-stored and ready to go. You can use predefined ones that we've built. You can use a large number from our catalog that our user community has built, or you can totally build your own if you'd like. Number of different Linux flavors, from Fedora to CentOS to Gentoo to Debian to Ubuntu. We've got Red Hat Enterprise Linux. We've got a demo copy of Windows Server the user put together, running on top of Linux actually, so it's a bit inefficient, but kind of a neat demo of what you could do. And we have Open Solaris as well. So those are at the operating system level. Number of different application stacks pre-built above that. LAMP stacks. We've got application things like Hadoop, which is great for doing large-scale parallel processing. MPI Blast, if you want to do gene sequencing. There's a pre-built AMI just for that. Takes just a couple minutes to boot up these AMIs when you make that request to the cloud. Like I said before, you have a full network security model, so you can control exactly how your instances see each other and how they can see the outside world and how the outside world can see them. Each geographic region broken up into multiple availability zones, with the idea being you got very low level or low latency access within a zone, and then each zone can fail independently. So if you want to do a very fault tolerant system, you can launch different server instances in different zones. Okay, you asked for some details of persistent storage. This is like a transcript of something I did. Excuse the tiny font size here. So basically what I did, I was sitting at home on my Windows desktop machine, and I did 2 command line calls. I said EC2 create volume, and both times I said I want, basically that huge number there basically says half a terabyte. So I said create 2 half terabyte volumes. It created those. It takes like a second or 2 to respond with those volumes. I get those 2 volumes. I do another command line call here, EC2 describe volumes. It says I have 2 volumes attached to my account. I then, still running from Windows, I said attach those to that I-6B over there is the identifier of my running EC2 instance. So I said attach both those instances to my EC2. I then hopped over to my EC2 shell. I created an X3 file system on each of them, and I created 2 mount points. I mounted those up on the machine, and I then had an extra terabyte of space attached to my running EC2 instance. That was about probably 5 minutes worth of typing and waiting for the file system to be created. So that's the basic set of operations you would do to create the volume, put a file system on it, attach to EC2, and mount it, and you're up and running. And of course, these command line tools I show here, these are just front ends for the actual APIs into the cloud to create those file systems and attach them.
So if you wanted to detach volume and reattach it to another AMI,
uh-huh.
You do that between zones?
That's a really good question. I don't actually know the exact answer to that. I believe that the volumes are created within a zone, and there's probably preferred access within the zone. I would envision that you can actually get zone-to-zone access. We have told our community that at a certain point we'll charge for bandwidth between the zones. I think we did say between the zones. We'll charge at a certain point for that. But if people are talking about using like multiple volumes and doing RAID across them and things like that, it should be pretty interesting. I'm expecting that the first month that we roll this out, we're going to see just 100 really amazing different kinds of things crop up as people get their brains around this and start to do different cool things with it. All right, this is a nifty Firefox management tool that we built called Elastic Fox. This makes it really easy to get started with EC2. What we have here, you start this up, use this little credentials button here to wire in the public and private identifiers to your Amazon developer account. We show you a list of all the available AMIs. You can simply click and say run, and then comes up a dialog that says how many would you like to run? And you then say 1, 10, 100, how many of you like. It enumerates all the running instances down there. You have other tabs to manage your key pairs for security and your security groups and your IP addresses and your zones. So sitting inside Firefox, you can actually launch a bunch of EC2s, see them as they're running, manage them, control them, attach IP addresses to them, and so forth. This is actually an open source tool, we actually put the source code out on SourceForge, and you're welcome to take this and customize it and send us patches and so forth. Anybody use this tool here? Work for you? Do what you wanted?
Yeah, it was okay.
Uh-huh.
Limiting right scale.
Uh-huh. Yeah, right scale is actually solving a slightly bigger problem. This is simply very, very direct access to the actual set of EC2 APIs, whereas right scale is saying, let me put another layer on top of that and actually manage what's running inside of the cloud for you. Okay, let me talk about a couple examples of cool stuff. This is a cool graph. I just got permission to do this a couple weeks ago, so I'm always love to put this one out. So the red line here is, and notice there's no vertical units here. I couldn't get permission to release the vertical units, but just these are basically linear. So let's say up means more, okay? The red line is the total aggregate bandwidth consumed by all Amazon's retail sites. So that's US, Germany, Japan, France, Canada, China. The red line, or the blue line over there, is the bandwidth consumed by all the Amazon Web Services, inbound and outbound. And you can see that started picking up in early 2006 and has grown to the point where it is now towering over Amazon.com's bandwidth. And this is for something that's a relatively young service. So you can see this is how important AWS is to us. You see that this is I sometimes get people ask, like, is this some kind of a test or a science experiment? Or you guys just kind of playing around with this? It's like, no, this is pretty serious stuff we're doing here. I think this just showing utilization should be just one indication of how serious we are and how serious our customers are about this. Okay, talk about this company. Was there a question? Oh, I saw a hand up.
I just noticed this little flat area in mid-2006 where you didn't have any really much increase in bandwidth. Were you guys thinking you had a dud on your hands there for a little bit?
What, this afternoon right here?
No, yeah, that's flat. Mid-2006.
Oh, right there? Oh, I have no idea. The blue one, right there. Oh, right there. Oh, okay, got it. I don't have any interpretation of what happened there. That was very, very early in the life of this. So when you launch these new services, you launch them, you get written up on TechCrunch and Dig and Reddit, and a ton of people kind of show up and say, well, this is kind of interesting. They try it out a little bit. It takes a little bit of time before it really gets into their brain, and they start really thinking, what is this all about? What can I use it for? What can I do? So people try it out a bit. Maybe they then back off a bit and then start thinking about it. And then they say, wow, I built my app, and away we go. We would never think after a couple weeks we have a dud. This is a really long-term investment for us. And one of the things I really love about Amazon is we really think for the long term. So when we're thinking about our web services investment, we really started investing heavily in this 2-3 years ago. We really realized this is like a 5 to 7 year investment for us to really get it to the size and the scope that we want it to be a really important business for us. And this is actually really our third line of business. We've got the retail website. We have the Amazon Marketplace, and web services is really the third big investment we've made as a company. So we're betting a lot on this, and we're really, really pleased with where it's gone so far. All right, let's turn to Animoto. All right, this is a really cool app. This is a dynamic music video generator powered by EC2 and S3. A very simple model. You go to animoto.com, you can create an account, you upload some images, you upload some music. They then use EC2 and their own proprietary algorithms to actually analyze the music, create a music video for you. They had some good success with this, and then they said, you know, it's working great as a standalone app. Let's put it out as a Facebook application. They did that, and everybody showed up. They literally went from 25,000 users on a Monday to 50,000 on a Tuesday to 125,000 on a Wednesday to like 250,000 on a Thursday. So viral growth from 20 to 250, built with EC2 and S3, and then with RightScale to actually manage the system load. Was pretty amazing how much EC2 they consumed. This was the graph. So for months upon months, they were, and months, so these are actually day tick marks at the bottom here. So for months and months and months back there, they were using just a little bit of EC2, 50, 60 instances at a time. Right there, like you can see the 15th right about the middle there. They're kicking around 50, 75. All of a sudden, things start to get kind of busy. And they're like, oh, okay, we're going to go to 500. They called us up, said, we're seeing some growth. We think we need about 500. So we said, okay, 500, that's fine. Go for it. Next day, we think we're up to 1,000. Okay, go for 1,000. And their usage for when I got this graph peaked at about 3,500. Later that week, they actually got as far as 5,000 EC2 instances running at the same time. So this is a small startup with 6, 7 folks in it. This is the level of scale that you can aspire to now as a moderately sized startup. You can't think anymore of what could I can only do what I have with my little set of servers I have. You can say, what can I get from the cloud? What can I actually do with it? And really think differently, I think, as far as amount of resources you can get and how you can use it. They didn't have to think about where they're going to get space, where they're going to get a data center. They didn't have to go to corporate IT and somehow say, okay, next year we need 5,000 servers. It was like tomorrow afternoon we need 5,000 servers. So this was at the point when they hit 5,000. I'd say that was kind of at the biggest scale that we were able to deal with at the time. And if we had like 10 customers all ask us for that much, we probably would have. I don't know that we could actually deal with an infinitely large number of customers asking for that, but by and large, we're going to see multiple customers asking for thousands, if not now, very, very shortly, and we're pretty much scaling up on a daily basis to make sure we can handle that level of growth. Yes, they have. In fact, and this was actually unrelated to their success. I believe Amazon actually invested in those guys. It turned out that that's one of the other neat things that happens in the cloud is we're seeing some really cool successes, and we say, that looks like a neat business. Maybe we should help those guys out a bit. And another cool architecture is a company called Podango, podcast processing. And they use EC2 and S3 and the Q service all wired together. Everything in the gray box runs in the Amazon cloud. So what these guys do, they got all these guys out in the field recording podcasts, uploading them to S3. They put those in this ingestion service right here. Ingestion service drops them over to S3. Now what they do is they record it in high quality MP2 format, but they want MP3s for actual processing. They use one queue and a bunch of EC2s to transcode from MP2 to MP3. Now the way they schedule this is really, really cool. They put a message into the queue and they say, please take one MP2 out of the storage, transcode it, and put it back as an MP3 into storage. When they put that message in there, they put a timestamp on it. They let that message work its way through to the queue and get processed. After it's processed, they then look and say, how long did it actually take for that message to go through the queue and to be processed? They compare that time to how long they would like it to be under ideal circumstances. If things are moving too slowly, they simply add one more processor to read off that same queue so they can actually process the queue a little bit faster. So as they pour more work into the queue, the system is effectively self-scaling. You put a big pile of work, says, my gosh, there's a lot of work here, it's running too slow. I'll just scale up some more instances. At the point when it's starting to say, well, there's not enough work to be done, it'll then shut itself back down and turn off the amount of number of machines that are running. Similarly, so they do the transcode once for every new podcast is uploaded. But what's uploaded is just a raw podcast. Just they say, hi, this is Bob, and they interview somebody, and then they end it. What they actually want to produce is a finished podcast with a series introduction and some ads and some announcements, then that raw podcast, then some more ads, and then the end of the series. So every day they recycle their whole podcast inventory. They pull everything out of storage, surgically stitch all that audio together to generate finished podcasts, which they then store back into S3. That's a process that they call assembly. And as they get more inventory, that assembly process is going to get bigger and bigger and bigger. It's actually grown to the point where they now have several hundred EC2s running for the duration of time that they do assembly. But once again, they simply pour all that work into the queue, and the system self-senses and realizes, I've got too much work to be done, it's taking too long. I'll stack up more EC2s up into the hundreds if necessary, get all that work done, consume it in a reasonable amount of time, and have those finished, reassembled podcasts ready to go. So again, relatively small company, but big aspirations, big dreams, able to scale up. And they don't have to have hundreds of machines there all the time. Once a day or once a week, or however often they redo that assembly, they simply put the work in there, system does the work, and then turns itself off when it's all done. Just about done. This is when you log into the portal, this is what you actually see for actual usage. You see a line item for each different service. And in fact, we've only covered a subset of the services. We haven't talked at all about payments or Mechanical Turk or a number of different cool things, only because I can't talk forever here. You can see I could probably talk for like 4 or 5 hours if you got me going about this stuff. There's a lot here that we have. So basically, you log into your account, and you can actually see line-by-line details of exactly how much you're using. So for example, this is my storage account from a little while ago, back when I only had 10 gigs stored. I now have about 90 gigs of stuff in my S3 account, so I pay a little bit more than that per month now. I think that's about it. Okay. On the commercial side, we make standard licensing terms. We make it really, really easy to get started. You go to the portal, You sign up as a developer. There's one standard license for every size of customer. We don't have to have lawyers involved back and forth with contract negotiations. Look at the license. Everything looks good. Click the OK. Give us your credit card number for billing. We give you a public key and a private key to make your requests. You can go home and you can start building your application tonight. You don't need to get any negotiation, no discussion, no approval. Just off and going with the service. Try to make that on-ramp as gentle and gradual as possible. And I think that's last slide. So more questions, more discussion?
So I guess I didn't get a very good chance to look at the actual specs of the EC2 servers. Are they?
We can go back there.
Well, I mean, no matter what they are,
yeah.
It doesn't matter. How are you going to handle sort of transitioning? I mean, because like CPUs and memory gets progressively.
Great. Okay.
So is it just like the sizes are sort of static, and you'll introduce larger sizes?
So the way these are measured is in terms of an abstract unit called an EC2 compute unit. So an EC2 compute unit is like a 1 gigahertz 2007 era Xeon or Opteron processor. Okay, so those are essentially our constant amounts of work. So as we get better hardware in the data center, and we've already gone through multiple generations of hardware, as we get more generations, we can take that same physical machine and slice it up ever more finely to run more copies of the same thing on there. So you can envision us over time, we'll roll out different kinds of ways to slice that same machine. More CPU, less RAM, and so forth are all ways we could actually do that. But the actual amount of processing you get for, let's say, a large should remain the same over time, but you could imagine us adding at the upper end of the scale as machines get more powerful. At the same time, one of the fundamental things about cloud computing is, depending on what you're doing, you probably don't need a lot of gigantic computers. You're often a lot more able to be flexible if you have a larger number of small systems. Because if any one of those goes offline, it's 1% of your workload gone rather than 10% or 50%. So if you build a very fault-tolerant architecture, you can then have a very fine-grained response to things failing or things getting too slow and say, put a little bit more capacity in rather than put a whole big chunk of new capacity in. Make sense?
I got a question about something you said. So on the small or large instances there, so is more that the large instance has 4 cores of the same speed, or does it have some?
There's actually, I actually used to have on the slide, I took it off. There's a combination of faster cores and more cores in the same. So I think with the extra large, you get, it is 4 virtual cores. Each they're twice as powerful as the low-end machine. So you effectively get virtual cores with the virtualization technology that we use. It's virtual cores.
I'm sorry. So you said that the large machine has 4 cores, but each core is faster than.
That's correct. Yeah. So the total amount of processing power you have is 8 EC2 units, where the unit is 1 core of a 2007 era Xeon. So it effectively can process 8 times as much stuff, but that's broken down into, I believe it's 4 cores, each they're twice as powerful. I need to actually check the website to make sure I have the facts straight on that. Question in the back. Okay.
Related to that, so does your code have to be parallelizable in some way in terms of how your code gets scheduled and how many processes you're running to take advantage of the?
If you're running multi-core, then you're going to want to run a good compiler that knows how to actually take your code and do multi-core code. And I know that different systems are going to be better or worse at actually exploiting multi-core. I actually was at a conference a couple months ago, and somebody said that multi-core is great for doing good benchmarks, and that was about it. I think that was a fairly cynical view of how good multi-core is, because I know people that have the right skills can get a lot more throughput out of a multi-core processor.
Do you know which languages that people are using or compilers that people are using that do better or worse?
I don't. That's one thing I would simply say, go to our discussion board and post a question there. We have a really awesome user community that you go to our discussion board and you post questions, and you get unbelievably high quality answers by and large. Satyan, does that ever come up in questions?
You know what, I'm not sure I've seen that, but when people see like, well, I'm really sure like,
Right.
If spammers are sending out spam, do you kick them off? And if you kick somebody off and they say, no, that was permission-based email, you get their account.
So what happens here is they actually subscribe to our terms of service, and there's a set of things that they're allowed to do and not allowed to do. And I'd have to read those things to say exactly what constitutes being a spammer. I know that people have found that the best way to send email is not to send it directly from these servers, but to go to there's like a third-party SMTP service that people actually tend to use to do really high-volume emails. If you're legitimately sending lots and lots of emails for legitimate mailing list kinds of purposes, people find that there's these high-volume SMTP services. I think it's called like Auth SMTP, I think is one that people use. It's like a third-party service that people will use in preference. From time to time, we do get reports of like, hey, guess what? There's a block of EC2s that are sending out junk mail. And I actually processed one of those over the weekend, passed it along to our operations center, and they then investigate and decide is that legitimate or not. If it's illegitimate, then we can shut it down. If we know that it's legitimate mail, and we might, at that point, we'd probably have had some kind of conversation back and forth to understand what it was, then we would say, okay, that's a wholly legitimate use of EC2. There's a fine line there, of course.
So real people look at it to determine whether it's legitimate.
I don't know the details, but I think that if we have legitimate customers doing good things with it, we'd want to keep them happy. And if we have people doing bad things with it, we'd want to make sure that they don't do too many bad things. So I know that those reports go to our network operations center, and there's an actual process we have documented that we step-by-step follow, but I don't know the exact details of how that actually happens. In the back?
Google recently released the Google App Engine. Right now it's pretty limited. You can only do Python last time I checked. But what do you expect some of the core differences to be between what you guys do and what App Engine probably will be doing for the customer?
Okay, so this one gets tricky for me to talk about for a couple different reasons. First, our policy is we generally don't talk a ton about competitors. And second, I have enough trouble thinking about our own stuff versus like knowing the whole industry. There's so many different things happening. It's really difficult for me to really know. I wouldn't want to actually, I can easily enough misrepresent our own things. I wouldn't want to misrepresent a customer, a competitor's kind of things. I suspect there's going to be a lot of different ways that people look at the cloud computing space and what they want to do and what customers might need, and say there's a lot of room for a lot of different solutions. One thing I know that is pretty cool is somebody actually built an app or a Google App Engine AMI and put it in our catalog within about a week, I think, of when Google rolled theirs out and said, okay, here's another way to actually run that kind of application. So I think they're really solving the problem at a couple different levels, and we're going to have to see over time what kind of things customers expect. You know, there's when I look at ours at the platform level, I see that we've actually got several different customers of ours that have built things very similar to that as applications running on top of what we do. So there's a company called Heroku, Heroku. You can go to Heroku.com. They have scalable Ruby on Rails hosting running in the Amazon cloud, and that's just one of the applications running. There's 2 or 3 different kind of applications like that where you simply say, put the application in the cloud, and then let us deal with the scaling automatically. So I think we'll see a lot of different things like that showing up on top of what we've done. Was that a good non-answer for you? Okay. More good questions? Cool. All right, well, we can continue talking more informally. I have no idea how much time we just used up there, because once I start talking, we just kind of go and go and go. But, oh my gosh, did I talk for 2 hours? Oh, okay, great, okay. All right, well, let's party and talk and continue on. Thank you all. Excellent. They were working with SOAP. They were trying hard to do web service kinds of things. But back then, if you think back to the web services state of the art back then, it was a buzzword that was floating around, and people were arguing about really esoteric aspects of the SOAP protocol and things like that. And then you say, show me something. And they would always draw the same picture. You draw the internet. You would then draw this their application connected up to the internet. And you draw this kind of cloudy thing. And you say, well, over here in this cloud, we have a stock quote service or a weather service. And if you're kind of geeky, you could kind of appreciate how cool it was to make a connection across the internet to that service and tell it to do something. It would do something and return the data back to you. Most people would look at that and say, this doesn't really do a whole lot for me. You know, big deal. You showed me the weather. You got me a stock quote. Not really all that impressive to people. So going on 6 years ago, I happened to log into my Amazon Associates account one day, and this little box popped up on the side, and it said, Amazon now has XML. I thought, oh, XML, I know what that's all about. I better check this out. Turned out that just that very day, Amazon had rolled out XML access to the Amazon product catalog. And what that way back in 2002, 2003 was called the Amazon Web Service, and has subsequently had a couple different names as we've really refined what that's all about. So I logged into my account, I signed up for this beta program, downloaded all this stuff, looked at it, and immediately thought, oh, gee, I've been doing XML for a while. I can tell these guys how to do it really right. So I sent up this big email to them, telling them all about what I thought, how it should be done. And so they quickly responded, actually, and said, we love all this feedback. We're very customer focused, so we want to have all this feedback from you. Come on over and tell us about it in person. So I thought, that's kind of neat. Went over to visit with Amazon. Couple steps later, helping, giving them some feedback. And then one day they said, we're getting pretty close to a release on this first web service. And this we're still for and things like that. We also do Office. Kind of the main thing we do that generates revenue for the company is to kind of help us break even is just to rent out this space, and we have 7 companies working here, and we have a couple offices still available, both on a day pass basis or month to month. So I want to talk about next month's countdown number 7. It will be about a design topic. It's about the site sampa.com. They just did a very major redesign of the website, and we're going to have the designer come talk to us about what it was that they recognized as problems in that website and what they did to address it and what kind of usability results they're seeing as a result of that. That site's been live, I think, now for about 2 months. So that'll be really interesting, I think, to see if what they expected to get out of it was something that they actually saw positive results for that design makeover. Also, immediately after this event tonight, we're having Nathan's going to be leading a pub crawl where they've made it to in the crawl. So anyway, we wanted to introduce tonight's speaker. Obviously, a major concern for software web service companies is how do you actually get your stuff hosted, and how do you get it live on the web? And there are a lot of very complicated issues with doing this well. And traditionally you could buy shared hosting or virtual hosting from traditional ISPs. There are lots of different options popping up now. It's actually kind of complicated to compare apples to apples. You have virtual servers and kind of the general category of kind of these bigger companies that are creating cloud computing initiatives where you're not necessarily buying space on one machine or one hard drive at a time. And so I would definitely say Amazon, with I think AWS has been launched for a couple years now. And I think it's a really bold move for a company to step out and recognize that this is a new emerging market. And they've obviously, taken the market by storm, and I think have had a lot of great success beyond a lot of people's expectations about how usable this, how useful this service is, and how much people needed something like this. And I think there's been a really strong demand for it. So with that, I'll introduce Jeff Barr, who's the senior web service evangelist for Amazon. All right, I'm not flat enough to be a good screen, obviously. Cool. All right. Well, thank you all for coming. So I love groups of this size because I can actually see all of your faces, and we can get totally off track if you'd like. Feel free to interrupt, stop, ask me questions, contest anything I have on the slides. I sometimes speak to groups of multiple hundreds up into thousands, and sometimes when you get to that size, you can literally not even see the audience. You get up on a big stage, and they darken the room, and they shine a whole bunch of lights on the stage, and you have no idea if there's actually anybody in the audience or not, or if they're falling asleep, or if they all got up and left, or if they're looking really, really excited about what you're doing, or if they're furiously coding away on their laptop while you're actually talking, which happens sometimes, which is always a kind of neat compliment. I've had people actually listen to what I said and then start writing code based on what I said before the session even ended, which is kind of a nifty thing to have happen. So just as a little bit of background, I've got a software development background. I've been writing code for a living since when I was 16, I worked up in Green Lake at a place called the Retail Computer Store. And this was back in the days of the Altair and the IMSI and so forth in 1976, believe it or not, 76, 77. Worked up there and done a whole bunch of interesting things since then. Moved back to the East Coast for a long, long time. Moved back to Seattle almost 11 years ago. Spent some time at Microsoft, worked on Visual Basic 6. I worked on HTML editing for VisualStudio.net. Had a real interest back then about programmable applications and even programmable websites, which kind of got me directly into web services. I always found whenever I used an application, the application was always pretty close, but never exactly what I wanted to. And so early customization and extension models for applications certainly I found really appealing. And then when I saw web services, I really kind of took customization and extension of sites and applications. Left Microsoft at the height of the dot-com boom to work with some venture capitalists, and these guys had a ton of money that kind of evaporated pretty quickly, but they had this really cool idea of letting me be their technical due diligence guy and sending me out to look at a bunch of startups that they wanted to invest in. And I would go in and check out the technology, check out the people, check out the markets, and kind of give them a go or no-go on what it is that they wanted to invest in. If I thought it was good and they put their money into it, I often would get to be in these new companies for a little bit and help them to get their first product or two out the door. I'd be their temporary CTO or their temporary engineering VP. That was really neat. This was back in 2000, 2001. And a lot of those companies that we were working with were all had this common thing. They were all working with XML.
All right, well. So welcome to StartPad. I'm glad to see such a great turnout tonight, and despite the sunny day, despite the Mariners game, and I think we have, one of the main reasons is we have a really interesting speaker, I think, this week, and a lot of people are interested in using Amazon services. So I'm going to give a quick overview of what we're doing here at StartPad. As I said, for people who are on the tour, we're kind of trying to create a community of software development companies, and in particular, fostering, is it the center button or? Oh, okay. So the things that we do, we're doing these monthly, you're projecting on my head, okay. We do a monthly lecture series, so this is the fourth Tuesday of every month is what the schedule we're trying to keep to now. And we will have both kind of business talks, technical talks. I think our next talk is about a design topic, and if you have other topics you're interested in, I'd love to hear about them, and we'll try to make it happen. So we also have a website, startpad.org. It's free to join that. What we've been trying to do there is collect a database of service providers. We've trolled through all the backlog of the Seattle tech startups mailing list. Anytime someone recommends a service or a service provider, we try to capture that and put that into an online database so that it's easier to get to than trolling through the last 1,000 emails that have been sent to the mailing list. And there's also a member directory there, so the members can find each other and maybe find people with skill sets that you're looking for.